what gaps and overlaps are there, and how can we better plan to implement and achieve scientific and monitoring objectives. So it's kind of like, in other words, how can we know where to go if we don't know where we've been or even where we are now? The challenge, however, is obtaining a comprehensive perspective at the regional or national scales and internationally. There are many tens of hundreds of observing systems, tens or hundred, well, really hundreds of observing systems across a fragmented, distributed landscape, if you will. But few of them share metadata about specific observing assets in ways that can be compiled or harmonized or assessed. So we're speaking here about individual observing assets like observing sites, and these could be platforms, instruments, or wherever repeat measurements have been made. This is sometimes also referred to as an observation facility, like under WMO WIGOS, or a research site, and meaning boreholes, moorings, flux towers, things like that. Or observing transects like buoy tracks, ship tracks, field transits, major infrastructure like observatories and field research stations, individually funded field-based research projects, expeditions or campaigns, and then the coordinating initiatives or programs, networks, research infrastructures, observing systems themselves. And that this last bullet there, there's a lot of overlapping concepts and definitions. But in other words, we're talking about observing assets above and beyond scientific data sets, if you will. And granted, there have been a few valuable inventories in the past of observing systems, networks, and programs by EU Plurinet, SAON, Intaros, mainly European initiatives, and then kind of just doing these inventories, static inventories in their own way each time, sort of, and sharing them in different ways. And there are many existing portals, we'll say, with readily accessible structured information about research projects, for example, on the left, or observing sites on the right. We know that there should not be just one portal. Most of these are defined by a geographic or thematic scope, or by governance and funding, addressing specific user audiences, most commonly for individual networks. But there are many more networks without readily accessible catalogs. And it should be pointed out that most of these organizations or initiatives, they put these metadata catalogs about observing assets together for their own internal purposes. So some of them share their metadata catalogs using established standards and protocols, in this case for research projects, like things like POAWG, ISO 19115, DIF, and a few others. And they also share with it through an endpoint with established transfer protocols like OAI PMH and OGC CSW, some of them. And then for observing sites, there are several, and catalogs with public-facing machine-readable endpoints about site level metadata, with ISO, O&M, WIGOS, WMO WIGOS, and a handful of transfer protocols. But this isn't that many, really. It's clear that there's a fraction of networks, only a fraction of networks share their asset level information as structured metadata with standardized machine readable access. So the real challenge here is a lack of interoperability across portals, and what we could generously define as catalog. Many share fields or metadata elements through custom metadata structures and vocabularies, reinventing the wheel each time, resulting in apples and oranges that are later difficult to harmonize. Most do not share the information, and many simply share the information as a table on a web page or a PDF. So there's much duplicated time and effort. So this leads to a mismatch of content. You know, some fields like the green arrows here, they transfer across, carry across no problem. Others are not quite the same, but can be harmonized. Others are problematic, close sort of, but not going to work. And then others have gaps, have on either side. So to dig into this a little bit more, you don't need to read the details here, but this is a little more following on the last slide, where the green fields translate without problem across different implementations. And the yellow ones require harmonization or adjustment. The orange ones are related but problematic, and then the pink ones are missing. And viewed in a different way, with information from a recent paper by Woner et al., you can see that the number of elements per metadata record across these site-level catalogs varies tremendously, and thus differing in the level of detail. So I worked for many years on AOV. It currently contains 36 networks, observing networks, with over 35,000 observing sites. It's an aggregating catalog, if you will, with a comprehensive perspective across multiple systems. And these are the 36 networks in AOV. Some of these are recognizable, but only 5 of them share metadata using a metadata standard. And so most of these networks were included in AOV through manual, laborious data wrangling and screen scraping, backfilling. And that led to understanding something had to happen here. So fortunately, there are lessons to be learned from the broader polar data community. And we're talking here about progress over the last decade or more with the improvements in interoperability for metadata that describe scientific data sets using established standards and control vocabularies or semantic technologies, having interoperable endpoints, some other tools. The whole idea here is for the end user to have access to information that is findable, accessible, interoperable, and reusable, the so-called FAIR principles. So this led us to start the Polar Observing Assets Working Group under SAON. The goals of making observing related information more fair, promoting best practices for interoperability, and to help span a spectrum, notably between observing and the data communities. And well, let me go back there just briefly to showcase and integrate across multiple systems. So the core group has identified these tasks, focused and hopefully achievable in the short term, to create a registry of observing networks, particularly focused on their interoperability mechanics. And task 2, to help provide some resources for translation and harmonization, particularly with vocabularies. And then the third is to provide a guidance document that would make it easier for individual networks or individual organizations to implement, to build and populate and share asset level catalogs. So hopefully then the outcomes will be a foundation for planning and integration across this fragmented landscape, improved interoperability, and then guidance to save time and effort. And indeed, that's what we found with AOV, is a lot of networks were really happy to run away with our ISO documentation. You were invited to join POAWG, particularly those familiar with networks or metadata management. and those networks or portals. But this is indeed kind of a bridge, like I said, between the observing data communities. And so we need to have some cross representation there, if you will. So want to showcase your network, interested in best practices, want an easier way to develop and share a catalog of observing assets, please click on that link and sign up. We'll have our launch meeting the 13th of May. Thank you.
Bill, can you put that link into the chat? And I was right, it is May 13th. That I thought it was the 16th. That's her.
Did I have it wrong on there? Yes, it is May 13th, Thursday, May 13th. It's come up that this is a holiday for a lot of Europeans or some.
Oh.
But I think we should proceed with that date.
Cool. So there's the link to the.
That's a holiday for Norway. That's a big holiday in Northern Europe.
Yeah, I'm hesitant to change it. What do you think?
Now, I'm not suggesting you do. I mean, it's hard to change those things. It's hard to keep track of all the Northern European holidays in May. A lot of them. What
we want to do is maximize U.S. involvement. So it's not. I'm kidding.
That's good. And we're sorely lacking actually in folks for the southern high latitudes. That would be good. Not really this audience. And then, yeah. If anybody can't make the first meeting, then it'll be monthly.
Yeah. Thanks so much, Bill. And I think, we can take a couple questions now, or we'll have time at the end if we want to follow up.
I've got a question, but I can save it to the end because I want to make sure we get the.
I don't know if next person dropped off already, but she typed something in the chat. Bill, can you help us understand when you're talking about interoperability, how is this the same as the kind of synthesis that she refers to here? The NPRB is about to do a synthesis of their research projects. So in this case, is this the same kind of interoperability that we're seeking?
So I'm not familiar with this latest synthesis phase for the North Polar Research Board. And I would like to hear about that. Alison and I spoke with the NPRB, I don't know, was that 2 years ago or so? And at the time, it seemed like they had a catalog of research projects, and Alison will correct me here, for just a portion of like one division or program or something under NPRB. And so maybe they're going to expand that. I don't know.
They had project level information available, but they weren't really at a place where they were ready to share that more broadly with the community. And they hadn't actually tackled site level categorizing for each project, basically, because that's we were starting down that road to figure out the easiest way if there's a way to pull a web service from them, and they weren't there yet. But they penciled it in 2 years ago as something they would consider moving forward.
Yeah, and so that brings up an interesting question for me is how valuable would it be for, say, NPRB to contribute the observing asset information as part of a synthesis phase, or are we really targeting the input of that metadata while the assets are being deployed, or perhaps even in a planning phase? When's the best point for any project or program to input their metadata?
Yesterday.
As soon as possible.
I mean, I think a lot of it comes down to the incentives for the individual network to share information, you know, and there are, I have a slide on this, but there's, you know, one of them is that they can identify co-located resources that they can take advantage of when establishing new sites, you know, power or access or telemetry or whatever. And And yeah, that's where we really need to focus.
Right.
And if I might add,
go ahead.
if I might add, we're also hearing that in order to foster more co-production of knowledge, it's important to have more of that information available during the planning phase. And so previously, our tasking, at least with AOV, was to compile information more as a look back and not to go directly to the PIs. But in the case of NPRB, they've also been working closely with AOS, the Alaska Ocean Observation System. And so they were contributing planning information, forward-looking about where activities were going to be happening for some of those projects. But, I don't think anybody's ever gone back and said, is this actually where you ended up sampling after all? So there's a bit of work to be done there, I'm sure.
Yeah, we can study that on the working group. But that is, I think, the only tie I see between these two talks. So I'm going to switch now to Lea Shanley's talk. I think it's really important that we, as a research community, make our efforts known to especially the local and Indigenous communities, because those assets are being deployed in their backyard, and they want to know about it. Maybe they'll have something to contribute in terms of study planning, but if we don't share that information ahead of time, it's very hard to do. So the next topic is legal interoperability of shared data. We were looking around in the community trying to find an expert in this topic to come present to us and give us kind of a foundation of a background so we can start addressing this on a more regular basis on the data team and observing team. And we're also interested in the topic of data sovereignty and seeing how the legal perspective can inform that discussion as well. So thank you very much for agreeing to present to us. And so we'll switch over to Lea.
Thank you. Can you see my screen all right?
Yes.
Yep. Okay. And I'm just going to leave it this way because otherwise it takes over both screens. So as we're meeting virtually from places across the country or the world, I'd like to respectfully acknowledge all Indigenous communities and their members. Wherever you are, you're on Indigenous land. And thank you for inviting me today to present before you. My background is in GIS and remote sensing for environmental monitoring, as well as participatory mapping, citizen science, and research data policy. As I mentioned, I'm going to be talking briefly about the group on Earth observations, work on legal interoperability of data sets, as well as touch on some of the Indigenous data sovereignty issues. So I'm sure many of you are already very familiar, but just in case, the Group on Earth Observations is an intergovernmental partnership working to improve the availability, access, and use of Earth observation data in a wide range of areas. Researchers need to understand their rights and obligations when we use someone else's data. The Earth observation community, and in particular the GEOS data sharing principles, have used such phrases as free, full, and open to convey this information. But this phrase does not provide enough legal certainty or granularity. For example, does this include value-added products or combined or derivative products? Can I redisseminate the data via a cloud provider? In addition, many GEO members and private industry use custom, lengthy end-user license agreements, or EULAs, to describe the allowable use. Accepting EULAs requires a legal review, and EULAs often include substantive restrictions on reuse, such as restricting use to only non-commercial. EULAs often contain terms that national governments are unwilling to accept, such as being subject to foreign law and indemnification requirements. This may result in lengthy negotiations on those terms. And as scientists, that's the last thing we want. Small and medium organizations that rely on access to open data are at a further disadvantage. They lack the resources to invest in counsel to understand the legal implications of the terms, and they don't have the clout to request that data providers, these big satellite companies, negotiate the EULA terms. Furthermore, the legal treatment of spaceborne, airborne, oceanborne, and ground-based data may be handled differently. Let's see, I'm not switching the right one here. Okay, slide. 4. Oops. All right. Sorry, I'm kind of going too fast on my slides. These issues have been explored for more than a decade, both within GEO and in other international groups. For example, the 2011 Legal Interoperability Subgroup Data Sharing Task Force recommended that GEO members should consider adopting one of 5 existing private law waivers or standard common use licenses. And I'm sure many of you are familiar with Creative Commons and Open Data Commons. With the recent push, to combine open data sets to leverage artificial intelligence, machine learning, and other cloud storage and computing techniques, however, attempting to combine data sets that are subject to different license terms have only compounded the legal issues. This has been dubbed licensing interoperability. Put simply, legal treatment of data has not kept up with the rapid advancement of data processing techniques. Furthermore, the lack of consistency between relevant international instruments, national policies, and legislation on the normative definitions and restrictions on the use of Earth observation or geospatial data may further limit the use of this data. Such inconsistencies make it legally impossible for some of our Group on Earth Observation members and private providers to share their data under an open license or in accordance with the GEOS data sharing principles. So GEO has known and studied this issue for over a decade. And in 2014, the Legal Interoperability Subgroup of GEO's Data Sharing Working Group presented legal mechanisms to share data as part of the GEOS, the kind of systems, observing system of systems data core. This comprehensive analysis was the result of years of work building on the prior work and identified and addressed all the issues I just mentioned. As with the 2011 report, it recommended the use of only standard instruments to help assure legal interoperability of data, and offered similar 5 mechanisms, which we've got listed here, that could be used to promote open access and unrestricted reuse of Earth observation data. However, then in 2016, the Research Data Alliance and CODATA also addressed this issue in a similar report, very nicely done and led by their Legal Interoperability Interest Group. They came to similar conclusions, again, listing some common instruments, Creative Commons, Open Data Commons licensing, which is consistent with the GEO findings. Nonetheless, despite these prior efforts and well-founded recommendations, only 50% of Group Earth Observation member governments have established national open data regulations and policies that allow agencies to freely share Earth observation data. So our Group on Earth Observations Data Working Group, or in our Ethics, Law, and Policy Subgroup, is in the process of developing a work plan to review these recommendations, assess the barriers, and hopefully offer some practical recommendations for implementation. So we're going to be focusing on taking those recommendations to action. Ultimately, we'd like to increase the use of open data shared among the GEO membership and cooperating private entities, while at the same time reducing the amount of time we all have to spend working with lawyers to review and negotiate custom EULA licenses. So the larger data working group also has a subgroup on in situ data, which I might highly recommend you invite Helen Glaives to come speak about their efforts, because I see that it overlaps with the presentation that came before me. And then there's a subgroup looking at updating the data sharing principles more broadly. So I'll entertain questions afterwards, but I'm going to transition briefly here into Indigenous data sovereignty. So this builds on work I've done with 4 American Indian tribes over more than a decade, helping them to build geospatial and Earth observation capacity, and also work on the development of data governance strategies. So there's a set of core strategies or core concepts, and I'm going to lay them out for the US tribes. I'm not a lawyer and I don't have expertise in international law, so I'm going to kind of lay out Indigenous data sovereignty as it plays out here in the US. It's important for us to understand that American Indian tribes are not another ethnic or special interest group. They are distinct independent political communities. This political relationship is based on 1, treaties and other legal arrangements or agreements, 2, on US federal Indian law, and 3, international human rights law. In order to discuss Indigenous data sovereignty, we must briefly review a couple of core concepts. First is that US tribes are sovereign nations with inherent powers of self-government over their reservations and trust lands. That means tribal governments have their own laws and regulations, and like state governments can enact statutes that govern data access by, say, if they had a tribal open records law or tribal privacy laws. Second, US tribes also have a unique government-to-government relationship with the federal government. So many of you may be familiar with the set of Supreme Court cases from the early 1800s known as the Marshall Trilogy, which formed the foundation of what's known as the federal tribal trust relationship, establishing a fiduciary duty and moral obligation to protect tribal lands, assets, resources, and treaty rights. Another very powerful concept, legal concept, is the doctrine of reserved rights. The Supreme Court has stated that in Indian treaties is not a grant of rights to Indians, but rather is a grant of rights from them. So they have reserved those rights which they have not granted to the government. So I would argue that, like states, tribes have a reserved right to control their own data. I'm going to skip over that one because of time. Through government-to-government relationship, the BIA and other executive agencies have a trust relationship towards federally recognized tribes, as well as a duty to consult with tribal governments regarding proposed federal policies and actions or scientific research that have tribal implications. These agencies create, maintain, and share spatial data and satellite imagery as part of this consultation process. So this goes beyond the Bureau of Indian Affairs, I would argue, to all federal agencies. In addition, university researchers, contractors, and other organizations also create and use data about Indigenous communities and their reservations. Based on history of colonization, systemic racism, and marginalization, American Indian tribes have long been concerned about the ownership, control, and access to their information and data about their lands, resources, communities, and citizens. While misuse of this data has been a longstanding concern, federal and state court decisions, as well as the development of sophisticated technologies for data collection, integration, and analysis, high resolution satellite imagery, big data, machine learning, have brought these issues to the forefront. As tribal meetings and conferences, I've often heard complaints about helicopter researchers who come to the reservation to take tribal knowledge and data without giving anything back in return. Tribes are concerned about those who can access their information, their data, their satellite imagery for a number of reasons, including, for example, through the Freedom of Information Act, third parties have demanded that government agencies and federally funded university researchers hand over tribal data despite confidentiality agreements and memorandums of understanding. This has resulted in the reduced bargaining power of tribes when negotiating leases with companies for tribal timber, rangeland, oil and gas, and minerals, resulting in lower economic returns. This has affected tribes' ability to assert their sovereign authority, including enforcing tribal air and water quality regulations within the boundaries of their reservation. This has weakened tribes' defense of their water rights and hunting and fishing treaty rights during litigation, and it's resulted in the infringement of tribes' collective sense of privacy and security, including unwanted intrusion of tourists on tribal sacred ceremonies, destruction of sacred sites, and theft of cultural artifacts. We have fundamental issues at stake here. Tribes' rights and interests in their knowledge, data, land, and resources, federal agencies' authority and decision-making that affect those resources, and on the other side, the public's right to know. The incorporation of tribal expertise, information, and data into federal environmental management, scientific research, and policy formulation is critical if tribes' rights and interests are to be protected. However, at the same time, if federal agencies and cooperating organizations are unable to protect tribes' privacy and confidentiality of their data, tribes may be unwilling to share their information. So that brings us to Indigenous data sovereignty. That's the right of Indigenous peoples and nations to govern the collection, ownership, and control or application of their data concerning a tribe, its members, and its lands. The right of Indigenous peoples and nations to control or reuse tribal data by third parties, including data collected for earlier research studies, is the beginning of discussions on Indigenous data governance. So there are now national and global networks focused on this issue, and they're working to develop tools and resources to support Indigenous data sovereignty, including an IEEE initiative to develop standards for tracking Indigenous data provenance. So how do we protect tribal data from potential misuse, while at the same time, we need to ensure that tribal government transparency and data access for tribal citizens, so it's a balance. It'll require a creative combination of technical, legal, policy, and organizational solutions. Tribes may strengthen their sovereignty by building internal capacity to understand and use spatial technologies and other emerging technologies to their own advantage, and by keeping abreast of new technologies and their potential implications. In other words, data science is the new frontier of self-determination. And what can you do? Well, I would say be mindful of your source of funding for the data you're collecting. If it's federal funding, it could become accessible under the Freedom of Information Act and other laws, policies, and regulations, even if you have a memorandum of understanding. So think carefully about the contracts that you set up. The other thing you may want to consider, in addition to FAIR, although we would argue that FAIR is not as open as the GEO principles, are the CARE principles. And so those discuss, the collective benefit, the authority to control, responsibility, and ethics. So I'll leave it now to questions, and I've included some resources here. The first one is a fantastic talk by an Indigenous scholar, hour-long, on Indigenous data sovereignty in the context of research, and particularly in biological research. So I think you'll find that very interesting. And then there's 4 additional resources. The ones by Carol are quite nice. They're a summary of the high-level issues. The dissertation's my own, and Dr. Robertson's are more deep dives, mine more into the legal issues around this in the US, and Dr. Robertson's more into the data science aspects. So with that, I'll close. Thank you.
Thank you. That was a lot of material in just 13 and a half minutes. So thank you very much for doing that. And it's really your time, people who called in. So I want to open it up for questions. Does anybody have a burning question for Lee or Bill about what's been presented?
And I just want to note, I know, Mike, you're on the phone. It's *9 if you want to raise your hand, or feel free to just come off mute and jump in. Sorry.
I have one raised hand. Dennis, do you want to
go? Yes, this question is for Leah. Thank you for that presentation on Indigenous people's data. I'm wondering if you have, with your expertise, or having any involvement with the IEEE provenance for Indigenous people's data group.
Yeah, I'm a member of that group through my affiliation with the group on Earth Observations, and I'm on one of the subgroups. But it's my first time on an IEEE group. It's a slow process. It's going to take 4 years, and there's about 60 people on the group. So I'm happy to connect you with folks on that group if you're interested.
Yeah, I kind of attended the meetings for a while and I sort of dropped off, but and I'm happy to hear that you're engaged with it.
Okay, thanks, Dennis. You should follow up with Lee offline. Mike?
Yeah, thanks, Jonathan. So Lee, I just wanted to say, this is Mike. I'm a co-leader of the Arctic Data Team. I thought that this, clearly you covered a lot of ground, a high level overview of a lot of content, but I think it's a topic that is really important and necessary to be in the body of knowledge, especially in the Arctic context where we're looking increasingly at co-production of knowledge. Clearly there are benefits and risks with that when you're talking about working with local communities, the tension between access and the benefits. And, there just needs to be more, I think, training for not only researchers, but also institutions like universities, for example, institutional review boards. I was really surprised as a grad student going through the process, and just like I felt like there was such a lack of capacity to pay attention to the really important nuanced risks with going and doing research with local communities. Clearly, I wasn't equipped with the knowledge of all the legal risks. As I'm collecting data for my study, I didn't realize, when I go deposit it on the NSF Arctic data site, there's, requirements that that data be disseminated. So I had to make the decision to not give all the data out, something I just wasn't ready for. One specific question I have for you is, excuse me, derivative products. I happen to believe this is like the key to really opening up a lot of access to data. Are you aware of, or do you think there's a need for a standard for specifying what a derivative product is in different contexts to kind of make it clear? It's not just, with this data set you can show a slide. It's with this data set, if there's more value added, you distance it from the source, you can really broadly disseminate it. So a few different ideas there, but I'm curious your reaction to that.
Yeah, I agree. I think it's important to kind of define that what the derivative products are. Some of these licenses that we mentioned do, I think, have some scope to that. I would suggest highly taking a look at the Legal Interoperability of Research Data report. I can send out a link to it in the chat box in a moment, but it goes through in quite detail a lot of this discussion that you're asking about.
And Mike, that's like the typical story. I wish I had more data management training when I was a grad student. That certainly applies in this topic as well.
Jonathan, I think you made a fantastic point at the top about co-creation, in designing the research before you even get started, reaching out to the communities at that point and making sure this is something that they're interested and have input in before you start down that path.
Yeah, I actually think that's a good nexus between the two presenters. And if we get to the point where we're trying to figure out systems for co-production and how do we work together, I do think this observing asset working group, that could be one of our main mandates or purposes for existing. Obviously, you guys have been doing this for a lot longer and have other reasons to be collecting this information. Identifying gaps, improving knowledge management, but I also see now Sandy's on with her camera on, so let's see if she has a question.
Thanks to you both for a couple of really great talks. I think the intersection that sprang up for me kind of builds on a conversation that Bill Manley and I had last week, where we often look at these maps, and because we're not knowledgeable, we don't know about the underlying map of whose territory we're on, or what the kind of authority, which authorities sort of rest within those areas. And I had shared a map layer that was developed, nativelands.ca, a Canadian map layer. And it strikes me again in this conversation that there's this very interesting intersection between thinking about, especially when you talk about sort of legacy assets, like we have a lot of legacy assets where we've probably gotten this very wrong for a long time, and we can do better. But I think part of that just starts with some visibility, some resources, and some awareness raising, where people even understand what the connection is between all those yellow dots and the communities who live around them, and how to find those communities and have conversations with them. And so I'm excited to see where this could move forward. I think it's an interesting intersection from where I sit.
So the Group on Earth Observations has established an Indigenous Peoples Alliance, and perhaps that might be a good group that you could reach out to build some connections. And many of those folks have deep expertise in observing systems, as well as coming from these Indigenous communities themselves.
Great, that's good comments. So William Ambrose.
Yeah, thanks. Those are really interesting. Well, there's a lot to think about. I've got a question for Bill. thinking back to your AOV work and the catalogs you're trying to put together now, how much do you know that you don't know? I hate to reincarnate Rumsfeld, but I mean, thinking, for example, about the Bering Strait. I mean, I know there are lots of moorings in the Bering Strait, and a lot of those are cataloged on AOV, but a lot of them I know aren't. And some of them, of course, we don't know about. That's the unknowable one. But I mean, what about Chinese moorings and Russian moorings and, all of that? I mean, that seems to be a large data gap. Is there any way to access any of that? Are you working on that?
There's huge gaps in knowledge and understanding and sharing. Excuse me. This is for comparison. This shows all of the interoperability across polar data systems, data repositories, as this Polder group put together the content and then this animation that you can manipulate. And it shows harvesting relationships, repositories that share their information in machine readable ways using standards. And so each one of those arrows is a automated harvesting relationship, and there's like 80 data repositories that share, and there's 50 that are aggregating catalogs actually. And so we are so far away from having anything like that for the interoperability about information about observing activities.
But a more simple, straightforward approach to answer William's question is, well, if there's a Chinese asset, the Chinese should enter that into the system. The originators of that asset need to be responsible for contributing that. So
there's kind of what needs to happen is a balance between top down and bottom up, and I think in terms of top down, it's beholden to individual agencies or organizations. Bottom up, I think there's growing interest in making everything easier for themselves as well as for others. And for what it's worth, the NIPR, NIPR, the Japanese data repository is taking a lead on I think that was sites.
Good. So we're at the top of the hour, and to be respectful of people's time, I'd like to wrap up. There is a question that's left in the chat, which we won't be able to get to, but you guys should take note of that, and we can try to follow up offline. Thank you, Javier, for contributing that question. So yeah, this has been a great meeting. Thank you to our two presenters and to a lot of good, interesting discussion from the people who attended today. So with that, have a nice day.
Thanks.
Yeah, thanks all. That was valuable.
Thank you.